In the last video, we studied about what is an ideal gas, and also we learned about the ideal gas law, and today we're going to solve some problems using that knowledge. So the first problem, I'm going to read it aloud, and then we're going to solve it on the board. So a rigid tank consists 1.5 moles of an ideal gas. Determine the number of moles of gas that must be withdrawn from the tank to lower the pressure of the gas from 25 atm to 5 atm. Assume the volume of the tank and the temperature of the gas remain constant during this operation. So first of all, I would like to differentiate between gauge pressure and absolute pressure, since in the second problem we're going to see what gauge pressure. So let's say we have a container that's in a environment at standard temperature and pressure, which means that the atmospheric pressure is equal to 1 atm. And let's say that the container has a gauge pressure of 3 atm. Gauge pressure is the difference between the pressure in the container and the environment, which means that the absolute pressure, or the pressure of the environment, plus the pressure inside the container will be 4 atm, since the atmospheric pressure is 1 atm. Okay, so in this problem we're given the absolute pressure. In the second problem we will talk about gauge pressure a little bit more. Okay, so it says that during that process the temperature and the volume of the gas remain constant. Okay, so let's see what we have. We have that at first the number of moles is 1.5 moles. Then we're looking for the amount of gas that should be extracted from the tank. Then we have the initial pressure is 25 atm. Then the final pressure is 5 atm, and we know that the volume is constant and the temperature is constant. Okay, so we're going to use the ideal gas law here. So I'm going to delete this in order to have enough space. Okay, so the ideal gas law is pressure times volume is equal to the number of moles times the ideal gas constant times the temperature. Okay, now we know that volume and temperature are constant, and also since this is a constant, that will not change. So we have that P1 over N1 is equal to P2 over N2. Okay, and now we can solve for N2, or the amount of, or the number of moles at the pressure of 5 atm. So this will be P2 times N1 over P1, or that will be 3 over 10 moles. Okay, so what we have now is N1 is equal to 1.5 moles and N2 is equal to 0.3 moles, and we're looking for the amount or the number of moles that are going to be extracted, so that's N1 minus N2, so delta N is equal to 1.2 moles. Okay, let's move to the second problem. Now in the second problem we're going to talk about gauge pressure. So the pressure gauge on a tank registers the gauge pressure, which is the difference between the interior pressure and the exterior pressure. When the tank is full of oxygen, O2, it means 12 kilograms of the gas at a gauge pressure of 40 atm. Determine the mass of oxygen that has been withdrawn from the tank when the pressure reading is 25 atm. Assume the temperature of the tank remains constant. Okay, now in this case, since in both cases we're talking about gauge pressure. We're not going to convert, or we're not going to calculate the absolute pressure, since it is not important in this case. Okay, so let's see what do we have. We have that M1, or the initial mass, is 12 kilograms. Then we have that the pressure P1 is equal to 40 atm. Then temperature is constant. P2 is equal to 25 atm, and we're looking for delta M, or the amount of gas in kilograms that's going to be extracted from the tank. Okay, now this problem is very similar to the last one, only in this case we're looking for the mass instead of the number of moles. Now, the ideal gas law was P times V is equal to N times R times T. Now, here the number of moles, we can write it as the mass of the gas over the molar mass times the gas constant times temperature. Okay. Now, from here we know that the temperature is constant. Then since this is a constant that remains the same, then also we know that the molar mass remains constant, and also the volume. The volume is not stated, but since the container of the gas does not change, which means that it remains the same, then the volume will be the same in both cases. Okay, so we have that P over M is constant. So P1 over M1 is equal to P2 over M2. And from here, M2 will be equal to P2 times M1 over P1. And if we plug in the numbers, we'll get 7.5 kilograms. And now, since M2 is 7.5 kilograms, and we're looking for the difference in mass, or delta M, we have that M1 is 12 kilograms, M2 is 7.5 kilograms, and we're looking for delta M, and delta M is equal to M1 minus M2, and that will be equal to 4.5 kilograms, and this is the final solution. In the next video we're going to solve some more problems about the ideal gas law, and then we're going to move on to the next chapter.